Hello, everybody, and welcome to the SD Times live microwebinar series with Melissa. Today, we're talking about using GPS location to obtain or target physical locations. In this 10-minute microwebinar, you'll learn how latitude and longitude coordinates can be converted into verified street addresses. This is the sixth and final episode in this series, so just for a quick recap, in episode 1, we talked about document verification. In episode 2, we talked about electronic identity verification. In episode 3, we talked about national watch list screening. In episode 4, we talked about golden records. And in the last episode, we talked about custom matching strategies. Those videos are all available on our website, so you can go back and watch those if you missed out. Now, with me today is Tim Sidor, Data Quality Analyst at Melisa. And now I'll kick things over to him.
Thank you, Jenna. A common use of geodata is taking a physical address, a known location, like 12 Main Street, and converting it to its known latitude, longitude coordinates, which in turn is then used to create a push-pin destination when using mapping applications, your typical smartphone application. But there's also a need to sometimes do the opposite. For database applications, it's the physical street address that's most often required for practical usage. No one says, let's pull up the property value for latitude 42, longitude minus 80. They say, let's pull up information for 12 Main Street or 4 Oak Street. So to take a geolocation given as latitude longitude pair and convert it into real verified addresses and other associated properties for that address is desirable and necessary to make real-time practical business decisions. And this service or a process is called reverse geocoding. Furthermore, looking at these coordinates, if they did not accurately or precisely represent the location and could be looked upon as a start point, some short distance away from the potential returned address, it would naturally be useful to know the distance between the two. So thinking of those visual mapping applications, the location and the distance, they look obvious, as you visually look at them, if not the same. But for database applications, the distance, it becomes quite important. So let's take a look at a few use cases. Say you wanted to use a start location to create a mailing list for targeted marketing, where a store's geolocation could be used to obtain X number of residential homes. It makes sense to target those only within a specific radius, the nearest, because they're more likely to make a short trip for a promotion. It can also be very costly, looking at it another way, in either direct mail, phone, or email campaigns to target addresses that are way outside a reasonable distance. That could lead to severing any chance of a loyalty customer experience, or just may not be that cost effective as a return of investment. Using that same model or same way of thinking in a slightly different way, businesses can also use a residential home's known coordinates to determine the nearest valid physical location of a store on their corporate list. Point them to the nearest Dunkin' Donuts or point them to the closest health stop in their network. This is common in what businesses call dealer locator services or applications. And it's usually configured to a finite list, a finite number of locations, and to a limited distance. And that will help produce the shortest, easiest path, or easiest path in a figurative sense, for a seamless customer experience. So it's important to always keep distance in mind when converting that location to a distance. In this case, the distance is applied as a radius from that starting point. The other important use case for reverse geocoding is for disaster relief mapping and emergency location purposes. In this case, you may know a location, but you can't distinguish or identify the address. And this could mean after a hurricane where damage is unfortunately spread evenly across now undefined property boundaries. Responders using GPS location can use reverse geocoding to find the address of that location or the locations. They actually walk the damage with handheld devices and using the geolocation to identify which house existed at the precise location they're standing at. It can also be useful in cases of aerial identification where the nearest residence or on-premise property owner information is desired. In rural locations, for example, wild bear on the loose or fire evacuation warnings are needed. We've seen things like this, real life applications, energy companies wanting to know the nearest residence to oil wells. Maybe there's upcoming construction or an incident they want to warn locals about. In all these cases, it's useful to be able to take a geolocation, convert it into the nearest verified address, or obtain a list of verified addresses with a certain distance, within a certain distance, and also to know the distance of these addresses returned from that original geolocation. And this in turn can be used in tandem with other services or products to query property values, household demographics, for example. Thank you.
Are there any limitations to the types of addresses that can be returned in this process?
It is configurable. For the most part, we like to see, or users like to see verified addresses, but there are options when using the service to say, okay, I want to get the nearest property, and that could be an undeliverable, uh, where the USPS doesn't deliver, um, or it could be an empty lot. So there are options where you configure, verified addresses, undeliverables, empty lots, and things of that nature.
So you mentioned calculating the address based on like the nearest verified address. So can you talk a little bit about how that distance is calculated?
Yeah, actually, the service underneath the hood has an underlying database of known locations. So think of it as for every address that we have those location coordinates. And what the service does, it performs a geospatial proximity search against clusters of those records at a time. It'll start from, okay, let's take the closest values to that location and incrementally get larger and larger and do more searches. Think of it as a growing concentric circle. So that's computed for all those different points until it arrives at uh, the limit distance, or maybe you only wanted one particular returned address.
Can you talk a little bit about how this process of reverse geocoding is different than like just like obtaining a list of addresses in an area?
Um, yeah, I think when you look at town municipalities and things like that, they have their own maps of valid addresses, but they're um, or for town bus routes or something like that for children's bus routes. They're probably like polygonal in shape, unshaped, and so therefore they're targeting large amounts of addresses, and it may not always be the closest. Whereas reverse geocoding, it all pivots off that distance. What's the closest to this point? So think of it as a growing radius. Um, and that's usually done on a limited number. The example we use is the nearest Dunkin' Donuts. You want to know within a short amount of distance, as that radius grows, what's the nearest location, and that's always a limited list.
Before we end here, can you talk a little bit about like Melissa's offerings for this type of service?
Sure, it's our service is called Geocoder. Uh, it's a web API, and just the nature of the data and our sources of data, that lends itself to being a cloud service solution. But actually, it does just as the examples say. You make a request with your geo coordinates, uh, the distance you'd like to search in, and how many addresses you'd like returned, and the response will be, okay, we found the closest one is, right on the rooftop level, or no distance, or there happened to be maybe 50 buildings within that half-mile radius you requested. So simple uh, web request response return.
Great. Well, that's all the time we have for today, and this also marks the end of this series on verification. Remember, you can watch replays of all the videos on sdtimes.com, and if you want to learn more about Melisa, you can head to melisa.com. Thanks everyone for tuning in.